Okay, let me to start because I don't want to postpone anything and I don't want to waste your time. But if you have any questions later, you can always ask me during the lecture, or you can send me email, so that is fine. Okay, so let me start talking. And you see my screen. The title of the talk is Unlocking Pentagons and Isfahani Inflation. I am absolutely sure that you never heard about walking pentagons. So this is really the first time when I will be presenting this topic. And I never published anything regarding this topic because I was keeping it for quite a while, just for myself to have time to experiment with this. And then I decided this year is just the final year and I can put it in public. So the first thing is that my name is Mirek Majewski, and if you want to just see a bit more about me, okay, just let me to go to the website. Okay, that's this thing. Okay, this is the ResearchGate website. The address is here, and the address is also on my presentation in the front. So that's me. Okay, I just look terribly old. But what you have here is this. You have all papers that I was writing in last few years. So you have part 8, part 7, going part 6, part 5, part 4, and then you're getting yes down. Okay, part 6 you have, part 5, part 4, part 3, part 2, part 1. Okay, and then some other things. So this website will give you everything what I do, what I published really in the last few years regarding geometry and geometric patterns. This talk is not there, so I will have to add this talk, but this is after this lecture. Okay, now let's change the sharing to my Geometry Sketchpad, and I can just close the Internet Explorer, so it will be not disturbing me and not taking space in the network. Okay, so you know this, and in this website I present practically everything what was published in geometric patterns, but there is really a lot of more. There are my personal notes that were never published, and probably they will be never published. Okay, so what I'm going to talk today, let's look at a few pictures. These pictures will tell you quite a lot. So that's a picture 1. We are going to talk about patterns like this one. This is a very specific type of patterns. I call them Kukl-Madras style. If you look at this one, you see that this one has one symmetry line and nothing else. You can try to find any other symmetry lines. There is absolutely nothing. The rest outside of the symmetry line is completely chaotic. Of course, left side and right side is the same, but otherwise each part is completely chaotic. We are dealing with identical shapes, and you have them quite a lot, and there is really few of them. So you have the petal like this, you have a half of the sun like this, and you have a goose feet like this, and then of course you have between them stars and arrows, but this is all. So this design is quite limited, but still It is very complex. So let's hide this picture and let's look into another picture, okay? I will remove this line, and here is another picture. This is another pattern in the same style. You can analyze this any way you want. You will not find even a single symmetry line. Of course, you can always say the right edge is symmetry line, but otherwise, there's no symmetry line in it. You can try to get things, okay, but you will be disappointed when you will find out that whatever you put as a symmetry line will not exist. This design is chaotic, but still fits nicely in the page. So let's hide this picture and show another one. This is again my Isfahan, and again the same shapes, but they are fitting quite nicely in this design. And again, no mirrors. So how they did this? Hide this one, show another one. Look at this. That's a crazy thing, and you can suspect that one of the mirrors is here, but this is not really true, because if you look at the top and bottom side, there is no mirror. For example, here you have star, the star is not. So this line is no mirror for this design. Although, when you're looking at this area, you're getting this question, okay, is this a mirror or not? So design is quite chaotic, but they managed to put everything in a way that is very consistent. Only these shapes that I did mention. Okay, so hide this picture and show the next one. Okay, that is Chahabak Madrasa in Isfahan again. And this design is perfectly fine. You can perfectly say, okay, that's a mirror, and if you look at this side is exactly like this one. These are just mirrors. So at least we got something that looks more organized, but still this question how they did this. Okay, so let's hide this picture and let's show this drawing. Okay, that's my drawing, and this is what I will be talking today. I will be talking about these pentagons, how they are built and what they mean for this design. But this is just introduction, and I need time to get to this drawing. Okay, let's go to the next page. Look at this. This is Bukhara in Uzbekistan, and they have a lot of buildings like this. What is the problem with these buildings? They're old and everything is falling down. So in last years, I was getting questions from them. Can you help us to recover the missing parts of the pattern? So for this pattern, this is what I did. Okay, I did this in the form of pentagons, and of course you don't know what I mean at the moment. Okay, but just in a few minutes you will know precisely everything. So this was the key to this whole design, to this right side. Left side is identical, so this is where we are. So for today, I'm going to talk about things like this. The first thing, what is geometric inflation? I'm sure that not many people heard about geometric inflation. Geometric inflation is something that was that came to the mathematical literature in a recent, let's say 20, 30 years, no later. There are not many good books about geometric inflation because, you see, due some, let's say, fake information, people started looking at some strange things that never happened really. So the scientific geometric inflation, there's only one good book. And if I can just share it with you, okay, just give me a moment, okay. Yes. Okay, do I have it here? Yes, I have it here. And I just, okay, a new share. And this is this one. Okay, that's the only book that I can trust, and that is talking about geometric inflation. But this book is quite hard if you're looking at, okay, just there should be somewhere the publishing date. Okay, you will find it later. Okay, this is 2013. So this is quite new book, and then there is a lot of theory, but this is heavy-duty theory. Okay, and this is just the beginning. But when you go further, you start getting hard mathematics and equations and so on. Okay, so let's go back to my presentation. We are back here. I will shut, okay, do I need, no, just a moment. I will shut the Penrose thing. So what is geometric inflation? I will try to explain it in a very simple examples, but I know that in this group there are also my students, so we will have to talk about geometric inflation in the future, because this is really the key to the many fantastic designs. If you remember, I wrote the book about the Topkapi scroll and patterns in Topkapi scroll. I talked there also about geometric inflation. So if you don't have this book, you have to go to Amazon and you have to get it. By the way, we had a series of lectures some time ago about geometric inflation and mostly in Iranian designs. So first, geometric inflation, then basic shapes for Kukul-Dash madrasa patterns. Then I will show you the first example, and this is really the main example. The key to everything. To everything what I will be talking today. So this example here, this is the example that gave the whole idea of walking pentagons. Then we will talk about a pattern from Chaharbagh Madrasa, the previous one that I was showing just a moment ago. Okay, this was not this one. This one. This is a really great pattern, and it is worth to look at it. And then we'll talk about what is happening when you put inflated pentagon on the edge of the pattern, and we talk about free and fixed pentagons. Then, if there will be time, we will talk about some variants, and this will be the most important part. So this is okay, the most. Okay, because this means really that if we can, for a given pattern, if we can produce variants of this pattern, and many of them, then our creativity is really huge. And then if there will be a chance, because our time is limited, I can talk about pattern from Hakim Mosque in Isfahan. It is a really hard topic, so I don't want to mess your time. And now let me to open the next file. Okay, do I have it here? No, I have to go back. Okay, part 1. Okay, do you see this file? The picture on it? So this is the beginning of the inflation thing. You can find on internet information about Penrose inflation for triangles. And this is really what will give you the whole idea how to deal with this. This is a fragment of a publication from somewhere, but I will just explain you what I mean. So when you start inflation, you always need, let's say, alphabet or basic set of tiles. So in this case, our tiles are two triangles. The first one is like this, 72 and 36 degrees angles, and this one is 108 angle on the top. The rest you can calculate. Now, they call them Penrose triangles, but in fact, these triangles were used in decagonal design for centuries. I think in 15th century, we already had designs with these two triangles. But these two triangles are quite important because we can divide them into something smaller. So we need inflation rules. So the first thing is, okay, is this. Okay, this is the alphabet, and let's make it different colors so you will know. Okay, so this is our alphabet, and then you need also a set of rules. The first rule, we have 4 rules. You can have them more if you want, but in Penrose inflation, we just prefer to use these 2 rules. So what these rules are telling, these rules are telling us how we can split one triangle like this, that tall triangle, into smaller ones. So you know how to do this, okay? So you get the triangle, you just draw a circle like this, and then you get the connections this way. And there are 2 ways, really, splitting the tall triangle into parts. One way is the left side, another one is the right side. Okay, so this is what we call symmetric or chiral inflations. We have 2 of them. You can make also inflation of this tall triangle in different way, but this is what is not used at the moment. Then the flat triangle can be also split into 2 smaller triangles like this. Just look, you just take a circle like this, and you get one tall triangle, and then you get another triangle that is the gray one, the small one. And again, you can have 2 rules, the rules like this shown here. Okay, and again, let's put them in, okay, in a kind of a background. Okay, let's put them this back, and let's change the color to, okay, it can be even this ugly now, yellow. This is fine. So for any type of inflation, it doesn't matter what kind of inflation you have, you need basic set of tiles, and you need the inflation rules. And in some cases, inflation will work only for one step. No many steps, just one step. In some other cases, inflation will work for many steps, and this is even more interesting. So let's look at this. So we have the same things. Okay, I will just shut it down because I don't need this. Yes, okay. And then suppose that we have a set of tall triangles. Can we have it? Of course, this is decagon really, in fact. And how we can inflate this decagon. Okay, I will start from here because it is much easier to do. So my first rule is like this, okay? So I can just put a thing like this. Okay, fine. And in this case, on the back, I have a big triangle divided into three parts. Now, the next step I can do like this, but this will be wrong. It will be completely wrong. Why? Because these points do not match anyway, and doing inflation of these things further will give us quite chaotic design. So we prefer to have the other rule, and we prefer to have this rule like this. Okay, so now let me to do this way. Every other one, okay, with this rule, okay, and now let's remove this thing because this is the background. I don't want to have it. Okay, take this one, and then we're applying this rule. So what happened here, we are inflating the whole decagon into smaller triangles, okay? Now, what you have to do, you have to just inflate them more. So again, you can inflate this one, fine. Okay, you cannot inflate this one this way. So you have to just go back. You have to take the other rule, okay, and then like this, and then like this, okay. So out of this, what we got perfectly all the shapes that we have here. We didn't go out of this zoo. Okay, we still are getting the same shapes. Of course, you can do the same with the gray triangles and so on. Okay, so this is what I was explaining, and this is what you get after the first step. Okay, I got it slightly differently, if I think. Okay, now I got it the same. Okay, fine. So this is this. Then if you start inflating the previous one in the step 2, you will get things like this. In the step 3, you will get something like this, okay? And then in the step 4, you will get even a more crazy thing. But this is not really important. What I wanted to show you, that inflation is quite powerful thing, and you can get out of this quite a lot. If you just take this design, and from pattern point of view, you can do quite a lot. For example, if you remove this segment, if you remove this gray area, you will get trapezium with 3 edges equal. So this will be giving you a shape that you know already, at least some of you know already. So basic shapes in Kukeldash Madrasa style, these are the shapes that we were showing on these photographs in the beginning. So that is this. So this is a very standard one, this is very standard one, this is very standard one. These 3 shapes here were used in, let's say, Iran. Let's put this down. Okay, and let's make the color, okay, just like this. So these 3 shapes were used in Persian design. This one, it is a very rare shape, and it was never used in probably never used. I never found it in Iran, but you can find it in the Western Muslim countries. For example, in Marrakesh, you can find a few designs with this shape. But of course, we can use it and we can get quite a lot of interesting results. Okay, let me put it down and let's open next file. Okay, and this is the pattern from Topkapi Scroll. Okay, it's coming, and that's the one here. Yes, this is a pattern that not many people noticed. Even if you have a book, the famous book on Topkapi Scroll, then you are just completely missing this pattern because nobody cares about this. It is very small, it is insignificant, and you cannot really get a lot out of this. But fortunately, I got a lot from this pattern. So let's talk about this. Let me to go just slide by slide, because if I start deriving things, drawing things, I will not have enough time. So my first thing is that how I can construct this thing. So I start from something, from a segment. Okay, just make this line thick, okay, and black. Okay, I start from a line like this. Okay, this line style thick. Okay, then I rotate it 144 degrees. Okay, I get this, and then I draw the line. You look at what you're having here. This is the right angle, so getting perpendicular line to this segment, rotating this segment about this point 144 degrees, you get the point B prime, which is the mirror of this point, and then you're just drawing perpendicular line. And in the next step, what you do, you just take this area and you divide it into chunks that are 18 degrees wide. Okay, so here every of them is 18 degrees. This is typical what we do in decagonal design. You remember in my previous talk on this conference, I was talking about this, and this is what you do. So you're getting a set of these lines. These are the lines that you're getting here. Yes, and these lines I can just make different color, so make them blue, okay, and make them dashed. So these are the blue lines are the division lines. They're coming to these 2 points, okay, and then you're getting what? You're getting these 2 points, okay, and if you draw a circle, you're getting also this. But what is the most important for me is this, that this way I get a pentagon. Okay, this is, I get a pentagon out of this. Simply, when I take these 2 points, I get this line, okay, and these 2 points, okay, Command Z, okay, make them red, and then a line medium. So they are breaking here and here. I get this line. This line is giving me 2 points, and these 2 points are enough to produce this decagon. So construction is very simple. Another pentagon I get from here. Okay, this is my another pentagon. And now look what is happening here. After drawing the circle, I get precisely these lines, the dotted lines that are in the Topkapi scroll drawing. So this pattern was a hint for everything, for the whole process. I have two pentagons. They look like this. And of course, I cannot use these blue shapes because they are useless. Okay, so I have to forget about them. Or the better is say, I have to join them with this, what is on the other side. And this one I have to join with this area. So you're getting the idea. Take pentagon, split it into triangles and trapezium. The triangles that are on the edges, remove and join them to something else. Okay, and this way you can just get a tessellation. Okay, if I just take these things out, if I take these things out, okay, and again these things out and this thing out, I can fill these things with this, what I was talking in the previous slide, with the pattern. So for example, here it comes star. Okay, that is the star that is coming here. Okay, so I get this pattern by just filling pentagon with the pentagonal star, trapezium with this arrow shape, and then tall triangle, but this shape. I get this, and then I can make reflections. So I can just take this, okay, and I can just take a transform, reflect, okay, and look what you're getting. You're getting larger shape, okay, and when you will go farther with this, you get a design like this. So the Topkapi scroll is really everything in this design. We are getting practically everything, and just from small piece like this and a very simple construction like the one shown here. That is really all. Okay, now let me to come back to one of the previous slides. Okay, and now, yes, okay, even this one. No, I think the one is better. Okay, I can undo things like this. Okay, so now let me to talk about what I mean by Isfahani inflation. Isfahani inflation is the division of the pentagon into parts like this. Okay, but in this case, you should ask a question. Do I have to do this exactly this way? What if I will just make something different? Okay, I just don't. Okay, yes, okay, I just need the points. So hide them. Okay, this is convenient to have everything in the background. Okay, and this one and this one. Okay, hide. Okay, so this is what I got. Okay, but I needed points. So let's go to document options, take this page and then duplicate this page 3 and go further. Now, in this case, what I did, we inflated it this way. Okay, let's remove this. We still have pentagon, fine. Okay, do I have inflation tools here? No, but I have them here. Okay, pentagon inflation. What about if I will inflate my pentagon this way? Okay. Can I do this? Of course, why not? If you do it this way, what you're getting simply different division of this thing. And now what you can do, you can just say, okay, fine. I like this part. I like this part. Okay, I don't like this. So I have to remove it. And I got trapezium. I have to say, okay, I don't like this. Fine. And of course, I have to join these two things. And then I have to do this. Okay. And then I got nice tessellation, really nice tessellation like this. Is different than the one that we had before, but I can to feel it with the pattern. So let's say, okay, so I can feel it with the stars. Do I have more stars? Yes, I have one star, one pentagon here, and then yes, a trapezium. How many trapeziums I have? I have them quite a lot. Okay. Okay, and then this way. And of course, there's one more. Okay, just here, reflect this point. So I can also put it here. And now what I can do else, okay, I can take the long triangle and I can fill it with the pattern like this. And of course, okay, so this way you see that you can play with these two initial pentagons and you can inflate them in a few different ways. In how many ways? Okay, just look at this. Okay. Yes, okay. Let me to open this file. In this design, we had only two pentagons. And these pentagons were attaching itself in a way like this. Okay, they had common edge, but they may not have common edge. This is not really important if they have common edge or not. But what you can do really with them, you can start inflating them in different ways. So suppose that we are inflating the first pentagon, the top one, according to the arrow. This is the direction of inflation. It is pointing to the trapezium. So each of these 5 on top are inflated down, but each of the bottom ones is inflated in every different direction. Okay, so here we have 5 different combinations, but you can just do like this. You can keep the bottom part fixed. Okay, this is the bottom part, up, left, down. Okay, up, left, down. But now inflate the top one into right direction. We are getting these red shapes that we don't like. At least the people in Iran didn't like, and they never use them. Okay, but that's not a problem. Some people like some things, some people don't. Okay, and then next step, again, keeping the bottom part, inflating the top part up like this. This is fine. Okay, and then this is getting 5 more combinations, and then inflating this way. This is still okay, and then inflating this way. So what we really got on each of these page one, okay, let's just keep it page 1, then this is page 2, okay, then is page 4. Okay, 1, 2. Okay, the page 3 was missing. Okay. Okay, this is page 4. Okay, and then it's page 5. So we got, in fact, how many? Okay, 5 times 5 combinations for 2. Okay, for 2 pentagons, really. Okay, I call them free pentagons because some pentagons can be fixed in some way and you cannot really do anything with them. So look, this is what you get for 2 pentagons. Now, if you think about 3 pentagons, then with the 3 pentagons, what you will be getting? You will be getting 5 times 5 times 5. Okay, this means it is equal 125. Okay, and then if you calculate 5 times 5 times 5 times 5, you're getting 625. Okay, and more and more. So this shows you that if you have combination of pentagons with 4 pentagons, you may get 625 designs, different tessellations. Some of them you will have to drop, but this is, let's say, for some time later. Okay, let's open the next document. Okay, and this is the Chaharbagh Madrasa pattern. That is the one that I wanted to show you, and this is what I'm going to keep talking about this to the end of this talk. Yes, okay, so I have, let's say, 7 minutes according to my clock, but I hope you will get the idea out of this. Yes, I have my bottle with water with me. This is lucky because I didn't talk too long, so my throat is burning. Okay, that's a beautiful door. If you go to Chaharbagh Madrasa, you may not see it because this is inside of the building and the visitors are not allowed to go there. I was lucky because I was with one of the architects who is living in Isfahan, so I could enter so many places where no one could go, no tourist could go. But what is this? Okay, let's look at this. The first thing is that if you look at this design, the first thing is how we can design this big contour. Okay, it means this area. Okay, make this thick and let's make it, okay, yellow color, not this one, hey. Okay, so the whole pattern is really this part, because left and right side are the same, top and bottom parts are the same. So if we know anything about this part, we know everything about this part. Okay, we don't need to bother about the rest. This part is nice. But then if you start drawing on this pattern, you will see what is happening here. First, this is the picture that you really know. Okay, make it blue. Okay. So this is the picture that you know from the Topkapi scroll example. That's looks like our pentagon split into tall triangles, trapezium, and these leftovers. Okay, so these two triangles I call leftovers because they are useless for this pentagon, but they are useful for some other things. And then if you look at this part is really again the same what you see in the Topkapi scroll. Then here you're getting design like this. So you're getting again tall triangles, trapezium, and leftovers. Then this part is again like this. Then this part is again like this. This is really half of the pentagon that goes somewhere like this. Okay, so this is what we are getting. So the first question always when we do a pattern like this is just start. You know, many people start from somewhere in the middle, but it is important to remember that we have to start with edges, because somebody who was doing these doors, they didn't start from the middle. He had dimensions the size of the space he got. So what we're getting here, this tall area, it is a combination of rectangles like this, where the angle between, between is 18 degrees. So all these are identical. Now again, look, how to start the whole thing. You have to construct the first pentagon. It doesn't matter which way you do this, okay, you have to start. In this case, okay, you just have to do this way. Okay, I didn't do it here because I expected that I will be doing further. So let's document options, add duplicate. Okay, two. That is fine. Okay, I just have to cut it down. Okay, I have to make it bigger. Okay, just like this. And then look what I'm getting out of how to get the first pentagon. The first pentagon you're getting this way. You're drawing a line. Okay, make it thin. And then you start rotating this line 18 degrees like always in. Okay, so 90 degrees by 5. Okay, and then with the minus because we want this line to go up. Okay, transform, rotate. Okay, that's enough. You see, you get this point, you get this point, and what you do, you just have to do like this. One circle, and this circle is giving me these points. Okay, display point style large. And these points are enough to make first pentagon. When you get a first pentagon, you start walking, just walking. You have, originally you have, okay, so original situation is like this. You have first pentagon, and then, okay, you take your pentagon and you start walking, and you can walk any way you want. Okay, really, this is my first pentagon. I can walk like this. Okay, they walked like this. Then I can walk like this. Okay, then I can walk this way. Okay, that's really what I can do. But I can do it different way. Okay, I can just try this one. I can try this one. Okay, I can try this one. Okay, and then I can try this way. Oh no, it will not work for me. Well, okay, I can do this way. If you go this way, you just get different collection of pentagons, and you can inflate them now. So if I do this way, I cannot inflate them and get this design because these are different pentagons, okay? But I'm just showing you in this moment, any collection of pentagons can be used to produce a design. But now there is just the inflation step, and I have to stop talking. Listen, if I have a pentagon on the edge, I cannot inflate it like this, okay? So because then I cut this thing, this trapezium in wrong place, okay? I cannot do like this because it will be still wrong. I cannot do like this. You remember, I can do only this, okay? I can do only this. I have to cut it along the symmetry line, okay? And this inflation part has only one mirror like this, okay? So, okay, let's keep it, okay? Now, what about this one? Okay, here, this pentagon, I can do it only this way. There's no other way of doing this, okay? Now, with this one, I can do it like this. That is fine, because you see, this part, if I scrub this part, I get trapezium and I can play with this. But I cannot inflate this pentagon in different way. No way, okay? I'm cutting against the mirrors. I cannot do this way, okay? I cannot do this way, okay? Well, I can, but this is just option, a very rare case, and I cannot do this way. So this was the only way I can really do, okay? What about this one? How can I inflate this one? So this pentagon can be inflated this way. Yes, okay, but then I get things like this, and I can live with them. But then I can inflate it this way. Yes, I will be quite happy with this one. I can do it this way, okay. I cannot do it this way, okay. Otherwise, I will go outside of this type of design, and I can do it this way. So the pentagons on the edge can be, okay, the pentagons on the edge can be inflated in fixed way, okay, and like this one, but the pentagon in the middle can be inflated in any way you want, okay. You can do it like this, or you can do it like this, or you can do it like this, or you can do it like this, and then you can inflate like this. And then the next step, just removing the unwanted parts. So this part I have to remove because I have to join the blue thing with something. Okay, here I'm getting this rhombus, which is not really what I wanted to have. Okay, and I think I have to stop talking and just have to stop sharing the screen and just ask about questions. Any questions you want? Any questions you want? No questions? Hello?
So it's really very nice pattern and nice lecture. So thank you very much. I just wanted to ask this in Geometer's Sketchpad. Yeah, am I audible?
Yes, yes, yes.
Yeah, so in Geometer's Sketchpad, all these inflation is inbuilt, or you have written codes?
Now you have to do it on your own. You have to create everything on your own, okay?
Right. And initially for this inflation, you took two triangles, right? But one can have more and then still do that. Once you define the set of rules, one can do that inflation, right?
Yes.
Okay.
Anybody else? No one else?
Hello?
Hi, Jinshong.
Yeah, I'm thinking of it in terms of recursive programming. Anything to do with that?
Recursive?
Yeah,
This is recursive.
yeah. But is it a nice way to do the programming?
No way.
No way?
Because you have to make your choices.
Yeah, that's right. That's right.
Okay. And you have many choices. So the programming will just fail in this. Okay. Just look at this. How many combinations you get? Let's say, suppose that, okay, I'll just let me to open one file more. Okay. And then file open. Okay. Yes, and I just want to share the screen. Okay. Can I share it in some way? The sharing doesn't work in this case. Okay. Okay, just for some reason I cannot share anything at the moment. Okay, just like this. Okay, just share the screen. Okay, look at this. This is what you're getting when you are dealing with the simple pattern, like this one. And you have really hundreds of possible tessellations. So here what you're getting looks this way. Okay, this is what you're getting. These are your free pentagons where you can do whatever you want. Okay, look at this. 1, 2, 3, 4, 5, 6, 7, 8. You have 8 free pentagons. Having 8 free pentagons, okay, calculate, okay, what you're getting. You're getting 5 to the power 8.
8.
This is the number of combinations that you get. So I don't think that any programming will make anything out of this mess. So this simple design that you have here, can give you such a number of different patterns. So the idea is, you see, the idea is quite useful because you can apply it and you can get quite a lot of results. And the one puzzling thing is that if you look at the designs of doors, people are copying only one design. The same design that you had in Chaharbagh Madrasa, people are copying everywhere. Okay. Okay, I think I used my time. Thank you very much. I hope you got something out of this, and I hope the video will be somewhere online and everybody will be able to look at it. Thank you.